the correct answer to this question is D. This question is saying that 1,000 people had a mean height of 60 inches, and I've taken 5 people. The mean height of my sample came out to 64. The mean of my sample is one value under the sampling distribution right here. This empty space includes the means of all other possible samples of 5 people that I could have chosen, but did not choose. So the correct answer was D. The correct answer to this one is B, because the empty space under this curve right here includes the means of all other possible samples of 5 people that I could have selected but didn't select. So it's B. The idea in this question is that here we have a population of people, and this is the height of each person. If I recorded the heights of 3 of these people, and I calculated the mean of their 3 heights, that mean would be one of the x's under here. So basically, if I take 3 x's from the population and calculate the mean of those 3 x's, that mean is one of the x's in this sampling distribution right here. So A is the sampling distribution. The correct answer is A, because B is the population that the samples are coming from. This one, A is a sampling distribution because sampling distribution is the means of all possible samples of one sample size, which is over here in choice A. Choice B isn't correct because these samples aren't all the same size. One of them has 4. So A is correct. They have to all be the same sample size to be a sampling distribution. Here, I've selected 3 samples of 5 people, and I've recorded their heights. And I got the mean of sample 1, the mean of sample 2, and the mean of sample 3. Those 3 sample means are in here, right here. And under this curve, we have the means of all possible samples that I could have selected. These 3 samples are just 3 of the possible samples that I could have selected from the population. So A is the sampling distribution. This is the sampling distribution. This right here is the values of all 1,000 individual people in the population, because these 15 people that I've selected are 15 individual people inside of this population right here. So this is the sampling distribution in which each value is a sample mean. This is the population in which each value is an individual person from the population. So the left is the sampling distribution, the right is the population. B, because in the sampling distribution, each value is a sample mean of a possible sample. In the population, each value is just a different person's value. These 3 x's aren't a complete sampling distribution by themselves, because the sampling distribution also includes the means of all other possible samples that could have been chosen in here. So no, the 3 x's are not a complete sampling distribution, because the sampling distribution includes the means of all possible samples. So the answer is B. Three x's here don't have a mean of 60, meaning if you added these 3 numbers and divided by 3, it's not 60, because the population has a mean of 60, which means that all of the possible samples under here, meaning all of the sample means under here together have a mean of 60. Because if the mean of the population is 60, the mean of the complete sampling distribution is 60. And these 3 x's aren't the complete sampling distribution. They're just 3 samples. So A is correct. If I actually, if the mean of the population is 60, and I had shown you all the means of all possible samples under here, then all of those possible samples together would have a mean of 60. So the answer is A. Also, B, it doesn't matter what the sample size is, because remember, the mean of the population and the mean of the sampling distribution are the same number, regardless of what sample size you're talking about. If the mean of all values in the population under this curve equals 60, then the mean of all of the sample means under this curve would also be 60, because these two distributions have to have the same mean, which means that the answer is B. This is the rule I told you. If the mean of the population is 60, the mean of the sampling distribution over here is also 60. So A is correct. B is not correct because the left curve right here is not the population. The population is the individual people under population members under this curve. So A is correct. The standard deviation of the sampling distribution over here is a standard error. The standard deviation of the population numbers over here is a population standard deviation. So the answer is B. Remember, a standard error is the standard deviation of a sampling distribution. So B is correct. The standard error would be the standard deviation of all values under the sampling distribution. I mean, the standard error would be the standard deviation of all values inside of the sampling distribution. It's not just the standard deviation of the selected samples. So B is correct. Once again, I'm selecting 3 samples of 5 and getting the mean of each one. If the population has a normal distribution with a mean of 60, the 1,000 population members have a mean of 60, and they have a normal curve. These are the means of my 3 selected samples under here. The means of all possible samples inside of the sampling distribution follow a normal curve, because like this, because if the population of people is normal, the sampling distribution of possible samples is also normal. That's part of the central limit theorem. So A is correct. B is not correct because these aren't, the bottom 3 aren't correct because these aren't sampling distributions. They're distributions of people, of the 1,000 population members. Here's the same question as before, but now the population is positively skewed. If the population is skewed, then once again I have my 3 sample means of my 3 selected samples, but the possible samples that I could have selected all follow a skewed curve, like this, a positively skewed curve, because the sample size of 5 is small. I'm selecting samples of 5 people, and when you're selecting samples of 5 people from a positively skewed population, you have a lot of the possible samples that are out there have low averages, and the distribution is positively skewed. So the answer to this one, question 13, is B. My 3 sample means are inside of a skewed sampling distribution that's positively skewed, just like the population. 13 is B. Now I'm selecting one sample of 30 people. This is actually 15, but we're imagining it's 30, from a population of 1,000 people. The population is positively skewed with a mean of 60. If I'm taking a sample of 30, then the possible samples of 30 that I could select follow a normal curve because of the big sample size. So the mean of my one selected sample will be inside of a distribution of, will be under a normal distribution of possible samples right here, even though the population that my sample came from is skewed. So A is correct. The normal curve is correct. This is just part of the central limit theorem. So I'm taking a sample of 53 people from the Cal State population, and I'm recording their heights. We're saying that our class is one possible sample that I could get, and the mean of our class is right there. We're imagining that our class has a sample mean of about 62. The average height of our class is about 62 right here. So these other 12 dots under here are just the means of other possible samples of 53 that could have been selected, because if I select 53 students randomly, I might get our class as a sample, but I might get another group of 53 people as a sample, and those other samples would have different sample means. So A is correct. This other sample out here is just a possible sample of 53 people that has a higher average or a higher mean than our class does. So this right here would be a really tall group of 53 students who have a really high average for their, because it looks like these are 53 Cal State students who have a mean height of about 72. So B is correct. This curve is showing B, the central limit theorem, because what it's saying is that we have the 5 red people who have a mean right here. We have the 5 green people who have a mean right here. So the red and the green are 2 possible samples of 5 people that could be selected from the skewed population. Since we're talking about small sample sizes, the means of these small samples follow a positively skewed curve. The blue and the orange are 2 possible samples of 30. This is the mean of the orange and the mean of the blue. All of the possible samples of 30 that could be chosen follow a normal curve, even though the population is skewed. Here, the green is a sample of 5 with their sample mean. The red is a sample of 5 with their sample mean. If the population is normal, the possible samples of 5, their sample means will also follow a normal curve. Because if the population is normal, the sampling distribution is normal. The blue is a possible sample of 30, with their sample mean as one mean under the curve. And all of the different possible samples of 30 that could be chosen from here, their sample means follow a normal curve, because if the population is normal, the sampling distribution is normal, regardless of what sample size you're talking about. So this is all just showing the central limit theorem. A large random sample gives you the most accurate information, so the answer is C. You actually get the most accurate information by collecting data from all students in the population, because that's the biggest sample size you can have. So the answer is C. this is statistical inference. Yes, it is, because you're collecting data from a sample to estimate something about the population. It's not statistical inference if you're using the entire population. So this one is A. This person is using a sample to estimate something about a population, but they know that they might have selected they know that they might have selected an unrepresentative sample by chance, and they know they might have gotten a misleading outcome. So they know that they're making an unproven conclusion. Whenever you make a conclusion about whenever you make a conclusion about a population using data from a sample, it's an unproven conclusion. So it's B. The median is exactly at the center because the median always has 50% below it and 50% above it. The mean is not always exactly at the center. If it's a normal distribution, the mean will be exactly at the center, but the mean is usually just roughly near the center. If the lowest value in the population, if the lowest value in the sample is 1 and the highest value in the sample is 100, the mean is going to be about halfway between those two numbers. So it's B. You can't spend an amount of money between 1 cent and 2 cents. So it's a discrete variable. The possible values are separated from each other because there's this space between them where no values can fall. So it's B, discrete. Dollar amounts are always discrete. You have different types of grocery bags. So it's a qualitative variable. We're not talking about amounts of things. We're talking about types of things. But then the possible categories, like the possible types of grocery bags, are all considered equal. There's no official order from lowest to highest. So it's qualitative nominal. Handedness, left-handed and right-handed people, is nominal because the two categories are considered equal. One isn't above the other one. Same thing for learning styles. You have visual learners and auditory learners, but those two groups of people are considered equal. One isn't above the other one, so 10 is nominal. Here you have a group of people who are unemployed, working the least. Part-time people are working more hours, and full-time people are working the most hours. So the categories do follow an order from lowest to highest. So it's an ordinal variable. Height is not an ordinal variable because even though the possible heights do follow this order from lower heights up to bigger heights, we're not talking about categories. We're talking about specific amounts. So it's not ordinal. An ordinal variable has to have values that are categories. An ordinal variable is something like child, adolescent, and adult, with just categories that follow an order. So this one is B, no. It's an amount of something, which means it's not an ordinal variable. Grade level and socioeconomic status are ordinal variables. Sophomore is not an ordinal variable because it's a category. It's not something that varies. Sophomore is just sophomore. So sophomore is actually a data value. It's actually a specific person's grade level. Eye color, well, eye color is a variable because different people have different eye colors, but those eye colors don't follow an order from lowest to highest, which means that it's nominal. So it's A and B. Different people have different grade levels. It varies. And also the different grade levels follow an order from lowest to highest. Different people have different socioeconomic statuses, so it varies. And there's an order from lower, middle, upper class. So these two are the ordinal variables, A and B. Upper class is a data value. It's not a variable. So it's not an ordinal variable. The other three are, though. So D is the answer for this one. If the recorded category, if person 1 says sophomore, person 2 says freshman, person 3 says senior, and person 4 is junior, grade level is still an ordinal variable because the possible categories follow an order from lowest to highest. The possible categories are still freshman, sophomore, junior, senior. It doesn't matter what order I record them in. It's still an ordinal variable, so B is correct. This question says, which of these following data sets would have the largest MAD variance and standard deviation? The one that has the highest spread would have the highest MAD variance and standard deviation, so A is correct. A has the most spread. If a person calculates a sample standard deviation and doesn't use the n-1 adjustment, they're likely to underestimate the population standard deviation, which means that D is correct. The second person who didn't use the adjustment is likely to underestimate. The person who did use the adjustment is likely to be more accurate. So D is correct for 22. 23. The person who used the n-1 adjustment is likely to be more accurate because, if the person uses the n-1 adjustment, they're likely to be more accurate because they're less likely to underestimate, which means that B is correct. The MAD is literally the average distance to the mean, because when you calculate the MAD, the MAD is literally the average distance to the mean, because when you calculate the MAD, you're just calculating the mean of all of the absolute deviations, which are just the distances to the mean. The standard deviation is a number that comes out close to the MAD, so the standard deviation is roughly the average distance to the mean, so A is correct.